Hello everyone and welcome. Today we are going to dive into advanced RAG, Retrieval-Augmented Generation. Standard RAG is great. It allows us to give a language model access to external documents. But standard RAG has a flaw. It relies entirely on basic vector search. Sometimes, a document shares similar keywords with a user's prompt but completely lacks the actual answer. To fix this, we are going to build a two-stage retrieval pipeline. We will use an embedding model for a fast, broad search and a Reranker model for a slow, highly accurate filtering step. Finally, we will pass the best results to an instruction-tuned LLM to generate our answer. We'll be running this entire pipeline on Kaggle using a dual GPU setup with two NVIDIA T4 accelerators. Before we look at the code, let's meet the three specific models powering our architecture today. First, our generator, IBM Granite 4 Micro. This is an incredibly capable 3 billion parameter language model. It is a decoder-only model fine-tuned specifically to follow instructions, answer questions, and excel at RAG tasks. We chose this model because it perfectly balances lightweight efficiency with enterprise-grade reasoning. Second, our search engine, QN3 Embedding. This is a 0.6 billion parameter text embedding model. Its job is to read our documents and convert them into dense vector math. When a user asks a question, QN quickly scans thousands of documents to find the closest matches in the vector space. It is lightweight, supports long context, and is heavily optimized for speed. Finally, our quality assurance judge, NVIDIA Llama Nematron Rerank 1B. This is the secret sauce of our pipeline. While QN is fast, it only looks at general semantic similarity. Nematron is a transformer cross-encoder. It takes the user's question and the retrieved documents, looks at them together using cross-attention, and scores them on true logical relevance. It ensures the LLM only sees the absolute best context. Let's jump into the Kaggle notebook. We are utilizing a dual-Nvidia T4 setup. First, we load our LLM, IBM Granite. Notice the parameter device map equals auto. This is crucial. Because we have two GPUs, the Hugging Face library will automatically distribute the model's layers across both T4 cards, maximizing our hardware efficiency. We also define a stream chat response function so we can watch the model type out its answer token by token in real time. Next, we set up our retrieval base. We load the QN3 embedding model. Then we ingest our data, in this case, a story text file. We can't feed a whole book to an LLM at once, so we break it down using a chunking function. We chunk the text into 80-word blocks with a 50-word overlap. Why the large overlap? Because we don't want to accidentally cut a sentence or an important thought in half. Once chunked, QN encodes all these blocks into dense vectors. Here is phase 1 of our search. When a user asks a question, QN encodes the question, compares it to our document vectors using cosine similarity, and grabs the top matches. It's incredibly fast, but it's just casting a wide net. To refine that net, we bring in phase 2, the NVIDIA Nematron Reranker. We load it as a sequence classification model on our first GPU, CUDA 0. Look at the prompt template and score pairs functions. Instead of comparing vectors, we are actually feeding the user's query and the retrieved document text directly into the Nematron model. The model computes a relevance logit, a precise score of how well the document actually answers the question. We then sort our chunks by this score, keeping only the highest quality data. Let's put it all together. The user asks, what is the color of his skin? First, QN fetches the top 4, most semantically similar chunks. We pass those 4 chunks to the NVIDIA Reranker. It scores them, reorders them, and we extract the top 3 absolute best matches. Finally, we build our prompt for IBM Granite. We give it the system instruction, you are an assistant. Use the following retrieved documents to answer the user's question. We inject the re-ranked chunks and ask the question. We hit run, and IBM Granite streams the exact answer perfectly based on the provided context. Modeled green. Because we used a Reranker, we guaranteed that the LLM wasn't distracted by irrelevant paragraphs that just happened to contain the words color or skin. We fed it exactly what it needed to succeed. By combining a fast embedding model like QN, a highly accurate cross-encoder like NVIDIA Nematron, and a sharp instruction-tuned LLM like IBM Granite, we bridge the gap between basic semantic search and truly intelligent, context-aware AI. And thanks to Kaggle's dual T4 accelerators, this entire advanced pipeline runs smoothly in real time. Thank you for watching and happy coding.